is HVM persistent per transaction snapshot. So I'll just explain the HVM state overall, and hopefully this answers the question. So Hemi, the HVM system maintains two different Bitcoin nodes. One of them is a lightweight consensus-only node. So basically header level consensus tracking what is actually the canonical chain. And then you have the full node, which is updated deterministically based on that lightweight view. That's with that 2-block lag. So the full node indexes data in certain ways based on the queries you want to support. So right now with HVM v0, for example, you can query for the UTXOs of a certain script hash or address, because you can convert an address to a Bitcoin script and then get the script hash. You could look up the balance of a script hash, so the sum of all the UTXO values maintained, and you could look at the current chain geometry, what is the current canonical tip. You could look at the transaction, and that's indexed by the containing block, so you're able to get transaction data and the block that it's contained in, and all of that is indexed in a way that's efficient to query. So there's nothing being stored in any direct smart contract state. Rather, what's happening is when you call an HVM precompile, it's stepping outside of the standard EVM execution and then talking directly to that deterministic Bitcoin full node to complete the query and bring that information back into the EVM, back to where the smart contract was executing, and then it can continue with that data. So for example, if you were to call the HVM precompile for getting the balance of an address, that's going to step outside of standard EVM computation. It's going to talk to the Bitcoin full node. It's going to get that balance. It's going to bring that balance back into the EVM, and then EVM execution continues with that value returned into the execution. So there will be, with HVM phase 1, there will be some minimal information that's maintained in a smart contract about chain geometry and basically a state root of that full node system. And there's some applications for that for ZK provability and being able to do compact proofs of HVM state in interesting ways. But the full node's really what matters, and the queries against the precompiles basically map to queries against an indexed data structure that is indexed in a way that supports efficiently completing